That works.
And you can download it.
Yes, that's perfect. Thank you.
Good. I think we're all set. Yep. And oh, I need to click on this. Oops. There you go.
Okay, got it. Cool. Hey, folks, welcome to the planetarium. And thank you to Krista for hosting us tonight. And you folks will have to let me know what you think of this. It's kind of an experimental class presentation mode. So we're going to start out with a little bit of a PowerPoint talking about water below Earth's surface. And then we're going to take a couple virtual cave tours. So here's our water cycle again that we looked at on Monday. And at that time, we talked about surface water, mostly focusing on rivers. And today we'll be talking about subsurface water, and we'll talk about a range of different kinds of subsurface water. And then because karst is the kind of subsurface water that I study, then that's what we're going to focus on for the rest of today. And then next week, we will be talking about oceans and then coasts. So here's kind of our transition from the surface to the subsurface. This is a diagram of what's called the critical zone, which is, as its name implies, it's critical. This is where life on Earth takes place. This is where all of our food comes from. This is where all of our drinking water comes from. It encompasses everything from the atmosphere and then down to the top of the saturated zone. So all of the, Earth's surface and all the places where water percolates down through the ground. So there are different types of critical zones, and they range kind of from one extreme to the other extreme. There we go, one extreme to the other. So on this end, we have porous media groundwater. And so this is what we would call a silicate dominated critical zone. So here the rocks are going to be more sands, sandstones, silts, things with uniformly distributed pore spaces in them. So the aquifers, where water is residing as groundwater, are kind of uniformly distributed throughout these silicate critical zones. Here, the thickness of the critical zone ranges from about 10 to 100 meters thick. And these are what we refer to as porous media groundwater aquifers when we're talking about the water that's being stored underground. On the other end, we have our carbonate critical zone. And so the carbonate rocks are limestones and dolomites, and this is where we have a role for the rocks being dissolved out by the groundwater and creating larger pore spaces up through caves. And so the water that's here is not evenly spread out. It's heterogeneous. It moves very quickly through the caves and larger pore spaces, and there's not as much water, and it doesn't move very quickly through the rock outside of those zones. And a little bit of terminology that goes with these. At the surface, you're going to see soil on both of these. In a carbonate critical zone, you're going to see this thing called epikarst, and that's where you have the surface of the limestone getting dissolved out, but it's just this very irregular soil rock contact. In both types of situations, you have a vadose zone. And so that's where groundwater moves through the material, but it's not stored there. So it's not a permanently wet area. And then we have our phreatic zone, which is the zone in which there's water pretty much all the time. So first we're going to talk about these groundwater aquifers, the silicate dominated critical zone aquifers, and then we'll talk about the karst aquifers. So when we're looking at these traditional porous-media groundwater aquifers, a lot of times you'll see these aquifers represented as a continuous rock layer that has water all throughout it. So in this case, we have two aquifers. So the rocks that can hold water in them will be aquifers. If you have a rock that does not hold water, it doesn't have enough pore space, it won't let water through, that can be an aquiclude if it doesn't let water through at all, or an aquitard if it really slows the water down. So humans get a lot of our drinking water from groundwater. So it's important to know how the wells are going to behave and how these water tables behave. And as you can see in this figure, they're going to behave differently whether they have a confining layer above them, so this confined aquifer, or whether the well goes into an unconfined aquifer that just sits right below the vadose zone with no impermeable layer over it. So we'll start here. We'll look at this water well. You drill a well here, and the water will sit at the level of the water table. When you have a confined aquifer, this water is under pressure, and so the imaginary surface that acts like a water table is up here with this dashed line. And so wells drilled into this will see water come up to the level of that dashed line. And so those are referred to as artesian wells when the water comes up under pressure and may rise higher than the surface of Earth. So knowing how the wells behave, here we're just looking at an unconfined aquifer. So there is a confining unit, but we're not looking at any aquifers that might be under it. We're just looking at this water table aquifer that's sitting right here. So we have our vadose zone up here, and below the water table, we have our phreatic zone. We have drilled a well here, and we've been pumping water out of this well. And what has happened here is that this recharging water that comes from precipitation in this case, it's coming into the aquifer at a slower rate than the well is pumping out. And so you get what's called a cone of depression because it's pulling water from all around on all sides and lowering the water table immediately around this well. And so you can imagine if there were a house over here and someone had their well here for their own personal drinking water, and they're pumping water, but it's at a reasonable rate and it's being recharged. Then let's put a factory over here that's taking a lot of water because they have to cool their equipment. This cone of depression, you can imagine, could spread out and could start to impact neighboring water users. Now we're going to switch over and look at karst aquifers. So here the situation is quite a bit different. In our Vedas zone, we still have water that you can find in the forms of waterfalls and streams that might flow through caves. And then this gets to a point where you have some cave passages that are within the phreatic zone, and those are completely full of water. There are hazards that are unique to caves, such as we have sinkholes that can form above karst landscapes. And while pollution of a porous aquifer, such as we looked at before, is a concern, it's a lot easier in that situation to make a basic model and see where your plume of pollution is going to go and work to clean it up and stop it. However, if you have a karst landscape, anything that gets into these sinkholes goes underground and into the groundwater very quickly. And unless you know exactly where the passages are, it's not as easy to track. You can't just make a model of where you would expect it to go because it's not uniformly full. You have these preferential flow routes in the forms of caves. So how do we get a karst aquifer as opposed to a porous-media aquifer? Why doesn't the water just kind of dissolve a little bit everywhere in the soluble rocks? So the soluble rocks here can be carbonate rocks like we discussed, or they could be like a gypsum rock or a halite rock or some other rock that dissolves easily. We need that chemical and mechanical weathering action that we've talked about. We need erosion. We need to move those materials through the cave passages or they won't develop, and all of this takes a bunch of time. So here are some examples of soluble rocks. This is Dolomite. All of these are rocks that have caves and karst aquifers formed in them. We can have gypsum rock, marble, halite or rock salt, and then the most common cave former and the one that we have around here is limestone. So as water comes down through the atmosphere and through the soil, it picks up carbon dioxide. It forms a weak acid. That weak acid, carbonic acid, hits the limestone and starts dissolving things. And so those dissolved ions travel through the water and through the caves to make caves. And then these things happen over time. This is an example from Mammoth Cave that we will be virtually visiting in a moment. And what we're looking at here is that the Mammoth Cave is, for now at least, is the longest cave system in the world. Got some pretty significant competition from some caves in Mexico that folks are trying to get. But being the longest cave system with over 420 miles of passage, it's had a long time to develop. And so this has been happening for about the past 5 million years. And so the passages in Mammoth Cave all feed out to the Green River that flows across the national park. And so the oldest passages are at the highest level, shown here as Collins Avenue. And so, you know, as these high level passages were forming, the water is moving through and it's down cutting in the floor of those passages, and the Green River is also down cutting. But, you know, when it's making these big passages, it's kind of at one level, and then you'll get an event where the river cuts down more quickly in its channel and it gets to a new stable point, and then the water inside of the cave works to catch up with that. It all wants to cut down and get to that new base level of the main river, and so then that's when it starts to form a new level of cave, and so that's where we have this all this level B passage in Mammoth Cave that's about 2 million years old. And then a similar story plays out, and it cuts down again, and there's another nicely formed level of passage at about 550 feet above sea level. So level C is about 1.5 million years old, and then the very lowest passages started forming about 1 million years ago, and there are some that are full with water and continuing to make new cave today. So, so all of these things work together: the soluble rock and the weathering and the erosion over long periods of time to make these large cave networks. And so here's kind of a different view. So we were looking side on at those cave passages. Here's a view of the geology and the water flow of the whole Mammoth Cave area. So we'll start down here in this little cross section. And so this cross section matches up with the orange line that's here. So this knob sticking up matches with this knob here. And the passages inside of Mammoth Cave are all beneath these ridges. So this, all of this green and more like a teal and this blue, this is all limestone. This makes up the sinkhole plain. We were talking about sinkholes and the hazards of sinkholes. This area, and you can see how it looks like, it looks textured. It looks like if you went up there, it would be all kinds of bumpy. This is a digital elevation model of the Mammoth Cave area. And so each one of these little bumps is a sinkhole. I-65 goes right across this sinkhole plain. And so you can imagine if there were, and there have been, wrecks of large trucks carrying all kinds of toxic things, and that material from the interstate can go straight into sinkholes, and then these dark blue lines represent trace flow paths of water. So again, if we remember that in your silicate-dominated porous-media aquifer, the water is kind of uniformly distributed. These dark blue lines represent those preferential flow paths where water is concentrated in this karst aquifer. And so let's say there was, you know, a wreck here and material got into this sinkhole. Well, we would estimate that it would follow this path and join up with these other waters here and then flow out to the turnhole bend. And so the cave resource managers in Mammoth Cave National Park maintain maps, and they know where these intersections are underground, and they could get in there to mitigate the effects of a spill like that. So this is all, you know, there are a lot of places where water goes into the ground, these sinkholes out here. Most of the large cave passages, however, are located up here. And why is that? They're underneath these ridges. So in purple, you can find a relatively less soluble rock. There's a sandstone that makes kind of a roof over these ridges and literally protects the cave passages from dissolving further. And that's part of the reason why Mammoth Cave is the longest cave system in the world. The next thing we're going to do is move on to our virtual cave tours. Does anyone have any questions about this map or the PowerPoint section of things before we move on? Okay, cool. I will,
oh yeah, you're gonna come
back
over
over here.
Yeah. Oh, and we need to be here.
Yeah,
And
let's start there.
and I stop this so it doesn't go around, and I hit that button, and I turn it over to you.
Awesome. Thank you.
I will put this down. Okay. All right.
Thank you.
Yeah, you're welcome.
Okay. Okay, so this is the historic entrance to Mammoth Cave. And so we can look down the steps. This is the route that you would take to enter the cave if you went on a historic tour. And let's just take a look around here for a minute. This road, can I make this be a like a laser pointer thing?
No, I don't think so.
No. Okay. So at the top right, you can see there's a
where you look. Oh,
this. Can I make? Oh, I could do that.
Yeah,
I didn't think about that. I was trying to use that.
Yeah.
Okay. Cool. So here there's a road that comes down from the visitor center. So from here, it's about a quarter mile to the visitor center, and then this road continues down past where that car is, and all the way down the hill to the Green River. But if we take a look back around here, this is one of a couple of entrances that was first discovered by the late Archaic and early woodland people about 4,000 years ago. And so try to imagine, maybe if we scroll up a little bit, imagine this without the stairs, just, you know, kind of a rocky, rugged climb down into the cave. Those people explored miles and miles of the Mammoth Cave system through here and through another entrance several miles to the east. They did so using torches that they made out of cane reed plants that they collected from near the rivers, and they wove sandals out of a plant called rattlesnake master. Okay. And that's what they used to explore inside of Mammoth Cave.
But rattlesnake master is spiky. I guess maybe there are leaves. The leaves aren't.
I don't know. Maybe they cooked it or something.
Okay.
Like the same way like people eat nettles.
Yeah. Huh.
Or prickly pears. So I mean, there are ways to deal with it, I guess. I'm not familiar with rattlesnake master. That's just the story that I know is that that was the weaving material that they had.
It's a pretty thick root. I mean thick leaf and tough, so I can see why it would. But and maybe the spikes are at the end, so maybe they just cut them off or something.
Maybe.
Yeah, we're growing some in our garden, so if it comes up, I can maybe bring you
yes, please. That would be fun.
Yeah.
So yeah, so these people were exploring in the cave. They mined minerals from the cave for medicinal purposes. And then about 2,000 years ago, there was like a hiatus in the cave visitation. No one really knows why that happened. And the cave was rediscovered in the late 18th century by a man named John Houchins. And it wasn't long after that that it got opened up to tours. So let's go inside.
So this is the Rotunda Room, and I'll just let this kind of pan around and then I'll show you some things. So if you take a look at the ceiling, that's why it's called the Rotunda. It's a really round room because of the way that the rocks have broken off to make that rounded ceiling. Okay, so let's stop it here. This is Audubon Avenue, heading out this way. And then if we scroll back around, now we're over here. We're looking out through Houchins Narrows, named after John Houchins. So that would be the way back out of the cave.
Is Audubon Avenue named after the naturalist Audubon?
I believe so.
Cool.
And then, yeah, there are quite a few famous folks who have their names on passages in.
Did he explore it
in Mammoth? Or? I think he if he was even there, he probably just took a tour.
Okay.
Same with Silliman, who's a famous mineralogist from Yale, and he took a tour. I think he wrote something about it, but he didn't do a lot of exploration.
Sure.
And then this is the way on to the rest of the cave from there. This passage is main cave. And so something to point out here, just in terms of human usage, I mean, of course, you can see the handrails and the interpretive sign and things of that nature. So people are using it today. But a cool thing to look at in the rotunda are all of these wooden artifacts. And so these are the remains of a saltpeter mining operation that was active during the War of 1812. So folks discovered that the sediments inside of Mammoth Cave and several other caves, like there are saltpeter caves in Eastern Kentucky. I know there's some saltpeter caves, but this is there's potassium nitrate within the soil, and it's really soluble. So you have to come into a cave if you're going to get that potassium nitrate, because out on the surface, if that soil develops potassium nitrate, but when it rains, it just gets washed away. So
it collects in the cave.
Well, I think it's kind of occurs in the same way in the cave sediments.
Okay.
And then what they did was they would take and that makes sense too. And I hadn't thought about it that way, but maybe there are deposits washed from the surface of potassium nitrate also. However, so they take the sediments and they would load them up into these bins inside of the cave. And if you look at the bottom of that bin, I wonder if we can get a better view. It's set up, I don't think we can.
If you pull up.
I don't know if we can. Yeah, we can zoom.
Oh, okay.
We can zoom on that. So take a look at these interlocking logs. So they would use the tulip poplar tree grows really super straight trunks, and they would cut those down, hollow out the center of the trunks, and that was their pipes. And then they would also have them hollowed out and cut in half. So you'd have these U-shaped logs that they could interlock, so that would hold the soil in. But when they ran water through it, it would dissolve the potassium nitrate and then let it seep out to the bottom. Then they would, this is the remains of a pumping tower. So they would bring that potassium nitrate solution up to a higher elevation than what's out on the surface, and then run it out through those pipes that they made.
That's for gunpowder and like bombs, right?
For gunpowder, yeah. Yeah, so they used that to make gunpowder for the War of 1812. And there were cave tours going on at the same time.
When was it discovered again? Discovered.
1780s. I do not remember the exact year.
Okay. For some reason, I was thinking 1830. Thank you.
You're welcome. 1830 is when one of the most famous guides was bringing tours through there.
Okay.
If you've heard of Stephen Bishop, he was an enslaved guide and just did an amazing level of exploration, and people would travel from all over the world and request him to be their guide in the cave. So here's just another example of the just the enormous size of these passages through Main Cave. I'll get a view out through here. And then on the right, and so now we're looking back out towards the entrance again in Main Cave. And this structure is another piece of evidence from human usage in the 19th century. This was built at a time when the cave was owned by someone named Dr. John Cron, who decided that it would be a really great idea to build a tuberculosis hospital inside of Mammoth Cave. There was anecdotal evidence that the cave air was like, people would come in the cave and they'd be like, all of a sudden I can breathe so much better. So he built this hospital and people were living in these stone huts inside of the cave.
It's more successful than any other tuberculosis hospitals, or like
it was
no.
worse. I remember reading about it. It was way worse, and it was compacted by the fact that they did this during the winter, so their tuberculosis only got worse and worse. It was the cold cave air really like worsened the tuberculosis, and people were requesting to leave, but the guy forced them to stay or something like that.
Yeah, and John Cron himself died of tuberculosis.
Yeah.
So go figure. So that's one of the interesting things that's happened in Mammoth Cave. So we're going to kind of take a leap to another section of the cave. This would take you, how long? It would take you hours to get there from those tuberculosis huts. And you'd have to go through some pretty narrow passages. Thinking 4 or 5 hours of moving through the cave to get there, at least.
So by narrow, like, would someone my size be able to fit through? Or like, how narrow are we talking?
Oh, I mean, you could, but you probably wouldn't be comfortable. Like definitely, you know, like I'd be moving sideways sometimes to get through there. There's some narrow canyons.
Okay.
So this is a place called the Snowball Room. Stop moving. So let's look at the ceiling. Here's the ceiling of the Snowball Room. So it looks like someone threw a bunch of snowballs up at the ceiling. And these are gypsum formations. So gypsum is calcium sulfate, and what's happened here is water, little bits of water moving through the limestone have interacted with pyrite. That's like, there are trace amounts of pyrite inside of the limestone at this part of the cave. And so when that happens, pyrite is iron sulfide. So your iron comes apart from the sulfur, and in this interaction, you also end up, there ends up being sulfuric acid involved, and that interacts with the calcium carbonate in the limestone. And what you end up doing is, in dry passages like this, when that chemical reaction makes its way out to the surface of the cave passage wall, the water evaporates and it becomes this calcium sulfate mineral. gypsum. And it can take all these different forms. So it can make these snowball forms. Let me see if there's any visible here. I know there's some in this room. Sometimes it makes little like flowers. So you can see, I mean, the walls and the ceiling in this whole room are just coated with this gypsum, as well as there are some really old signatures. So this area, people did make that journey I was talking about, going through those narrow passages, and they made their way. It looks like, you know, at first glance in this image, it looks like that could be spray paint, but it's not. This is candle smoke writing from the 19th century. This is an advertisement for Hoofland's Tonic from 1869. Here's a super famous one. And someone wrote this, made this inscription on the wall to Nick the Guide. In 1857, Nick Bransford was another enslaved guide in Mammoth Cave. He couldn't read or write. Some of the slaves who worked in the cave did learn to read and write. They were taught by visitors and things, but Nick could not. And someone made this for him on the wall. And he was the beginning of a legacy that continues to this day. And I don't know how many greats, like great, maybe 3 greats, grandson is currently a guide at Mammoth Cave National Park. So he works for the Park Service, and he is really quite amazing. So if you ever have a chance to get a tour with Jerry Bransford, it's an amazing experience. So let's move on. Stop 4 is not pulling up. There it goes.
The computer is doing a lot, so I'm not surprised that it's slow.
Okay. This is a little ways down from, this is a cool place. Stop moving. Okay. So this is really close to the snowball room we were just looking at. So this is a paved trail. And while I said it would have taken, 5 hours to get from the tuberculosis huts to the snowball room, nowadays there's a few other easier ways to get there, one of which is an elevator that goes right down to the snowball room. And there are accessible tours that they run through there. And so there's this paved sidewalk, and people can go down the elevator and through the snowball room and out. This is Cleveland Avenue for quite a ways, and it's a nice tour. So anyone can take a tour in Mammoth Cave, which is really awesome. Yeah. So Cleveland Avenue is really quite special. If you remember, I talked about those levels of Mammoth Cave, with the oldest ones being level A, and then the next ones were those level B. Main cave that we looked at was level B. This is a level C passage. And you can see that its cross section is like this perfect oval. So people think that this formed right at the water level. And so this was the water table whenever this passage was forming. And so it just made this perfect tube, and just, the river wasn't cutting down very much at that time. And so it was able to just stay there at that level for a while and just dissolve out this really perfect tube. So let's take a look around and see if we can see back to the snowball room from here. How far are we? We see a little pile of breakdown where rocks have fallen from the ceiling. That would have happened whenever the Green River did cut down and start forming level D. And all of a sudden, all of that buoyant support in the passage that was holding that ceiling up, where it was a little crack there, that water support was taken away and those rocks fell. Okay, so what else do we have for Mammoth Cave and how are we on time? This is a pretty area. This is showing some solutional features. So this would have been formed not right at the water table, but there would have been a river flowing through this with a free surface on the river, because you can see how the limestone isn't just in a smooth tube, but it's kind of this canyon and the rocks are sculpted out in different ways at different places. And that would have happened from turbulent water flowing through in a free surface river flow. And that is all for our Mammoth Cave tour. We're going to switch gears for a moment. So we've been, in this class, we've been almost exclusively talking about United States national parks. For the next 20 minutes or so, we're going to visit a national park in Vietnam. And I can really use your help getting this dialed ready. Okay, so here's this. Okay. Yes, great. Okay, and
is that the island within the cave within one?
That's
Nope.
And
There we go.
Perfect.
Okay.
Okay, awesome. Thank
There you
you.
go. And I will okay, and you want me to close? Oh,
That one here.
oh,
Okay.
What?
Oh,
Wait.
what? Why?
Okay.
Well, we can.
Oh,
just
you can click on
there.
entrance. That's right.
Okay.
And I'm
then
gonna get
we'll
full
close
screen.
this. Okay.
Okay, I'm gonna click on F11.
Yep.
And you want me, and I'll close
Those
this.
are the, or leave the map.
You can
I think that's
turn it
good.
on and off with this.
Yep. Oh.
Yeah.
Oh.
Why is
But
that?
if you roll over it, you can read it.
Okay. Cool. Thank you.
Yes. I actually have a shade about like a 15 show about finding water underneath using satellites. To find water.
Interesting.
So if you end up with this minute,
Okay. Cool.
yeah, which I forget well, which I didn't. Well, I didn't look at the title of your study.
Okay, so this is at Phong Nha Ke Bang National Park, which is in Vietnam. And the cave that we're visiting here is Sandoon Cave. And so this is, has some of the largest, it's one of the largest caves in the world by the volume of the cave passages. And so we're going to take a look around and see what this jungle environment is like. I've never been there. I know people who have been to the area. There are tour guiding companies, you know, like if you were to go right now to the New River, for instance, there are like 5 different rafting guide companies. It's the same kind of thing with some of these caves in Vietnam. You can sign up and take a guided tour. So now we're just inside the entrance, and so this cave has only been known about for a little while. It was discovered in 1991, but the person who found it just didn't right away record where it was, and he didn't go back again until 2009, and then they brought back, so he was a local Vietnamese man, Ho Con, and he contacted some British cave explorers who then returned to begin mapping the cave. And so there's a steep slope that has to be climbed down the side, and take a look, we can see back up towards the entrance. So had to climb down quite a ways to get in there. And so we've talked about we talked about a couple different kinds of cave deposits today. We talked about the sediments you get inside of caves that are, and those are washed in from outside, the sediments they got the saltpeter from. And we talked about gypsum that precipitates out on cave walls. Another kind of cave deposit is the stalagmites and flowstone that happen on cave walls, and those are made out of calcite, which is calcium carbonate. It's the same mineral that the limestone is made up of. So the water that forms the cave can bring that calcium carbonate inside and then redeposit it, and it is just everywhere in this room. Again, looking back out towards the entrance. Back around. The ceiling is really flat. Yeah. Okay, so let's continue on to where they needed to cross the river. So this is like a fast river. You have a road set up. So this passage is large enough. This significant river that's fast enough that people need to use a rope to be stable to cross it. This is at low water levels. So during monsoons, like we wouldn't even be able to get across the river. And moving on, we're going to the Hand of Dog. So this footage is taken from the top of a stalagmite. So you can see if we look down, so that's a stalagmite that you're on top of, and there's a person standing kind of where that arrow is pointing. I mean, where did I put that laser? That's a person. Wow. So this is really huge. So this the passage is it's large enough that you could fly a Boeing 747 through it. Oh. So this is absolutely enormous. This is one of the biggest underground chambers in a cave. The stalagmite out here, that stalagmite is called the Hand of Dog. It is more than 70 meters tall, so it's about a 200-foot tall stalagmite, which they think is probably the tallest stalagmite in the world. And so, yeah, it's called Hand of Dog because the first explorers were like so amazed. They're like, let's call it the Hand of God, but they didn't want to, like, they didn't feel right doing that, so they called it Hand of Dog. Yeah. So much flowstone. That's just how the crystals form in flowstone. It sometimes looks almost velvety. It's not. It can shred you, but it does have a very like velvety looking texture to it. Sometimes like up here, it's just really, really white. You just get, and it's amazing the variety of colors that you can see in cave. Okay, so we're going to now get the view from on top of Hand of the Dog, where that person is. So, so if we turn around, we can look to see where we were before. So we're on Hand of Dog, and that's the stalagmite that we were looking at before. And then you can see a person there. Again, for scale. And so if we zoom in on this, we should be able to see you know, some of the impact of humans visiting.
Oh, that's good.
Yeah, so this is looking straight down on Hand of Dog. And over there, you can see a camp. So this is for running expeditions, mapping inside of the cave. What was that?
I'd be surprised to see a fire in the cave. Usually that's like, you don't do that in the cave.
True. It's also really, this is near an entrance as well. Okay. So we're like going right through. So we're going, so this is called Dolomite 1. And so if you look on the right, you can see that can kind of follow along on the cave map that they made. So right now we're at this Dolomite 1, and so a dolene is another name for a sinkhole. So up on the surface, people would see this sinkhole, but we're still kind of in the cave, but it's got this skylight at this point, and so that's why I guess they felt like they could build a fire, which is that it's really well ventilated right there. Okay, and so this is what Dolomite 1 looks like from the surface, or closer to the surface. We're still long ways down, but we're up on this vegetated area, kind of almost a saddle between parts of the cave, it looks like. I think that vegetation behaves differently there than we would expect to near here. So I don't know what the age of the sinkhole would be. I'm guessing old-ish, like on the order of, you know, not our lifespan, like maybe thousands of years, but not geologically old. It is a jungle, so stuff grows up a lot faster there than it does around here. So this is the first Dolomite. So this is called. So they've named this Dolomite. Watch out for dinosaurs is the name of this. So here is Okay, so we went the wrong way. We're up in the Dolomite. Okay, so we're going to move on to another stalagmite here. So we're still have sunlight from this Dolomite or sinkhole. This is a stalagmite that I'm guessing would have formed before that sinkhole collapsed. So this would have been inside of the cave. And so they've used the some of the chemical impurities or isotopes inside of the stalagmite to date the cave. And so what the estimate is this cave is about 2 to 5 million years. And so we get the view from on top of that stalagmite. And so this, these pictures were taken, I think, with a kind of a camera called a gigapam. And so that just gets these, you can get super high resolutions at pretty far away. What's that? Yeah, they kind of take the like the path of water dripping down. So the water drips down and they kind of spread out. And I would imagine that, like, some of them are wider and lower, some are taller and more narrow, and maybe that has something to do with like the rate of dripping and like how far they are from the ceiling. Right. Okay, and so now we've gone past that Dolomite and back into the darker area of the cave. So this is a short section of cave between the two Dolomites that you can see here. And so this is we have more huge stalagmite-like features here, and then flowstone coming over the sides, and then this kind of deposit. This is still a calcium carbonate deposit that's formed here. These are called Rimstone Dams, and they form at the edges of underground lakes. And so if you get this lake that has all this dissolved calcite or calcium carbonate in it, then it starts to precipitate out its own dams at the edges of those lakes. And then if we go back here, we're probably looking back out into that first Dolomite. Oh my, that's a view. And then we come back around and we can continue toward Dolomite 2. Yeah. So there's only like a few hundred meters in between the two Dolomites. But it's where we just were is still like right here even is far enough from the entrance that without using extra lights to light it up, this would be it would still be very dark here. You might be able to see the sunlight at the entrance. You'd be able to see that there's an entrance there, but we're still very far from it, and you wouldn't be able to see far enough to walk safely. So you can see the trail that people have used to move through the cave, and we had to zoom in quite a ways to see people on this trail. So going out to, so this is Doling 2. And so there's, you know, different plants that grow in here just because it's a different kind of environment with a low light. And so just something to observe here. Plants are a little bit bigger, you're closer to the sunlight, and so, you know, and on your way back out to the surface, the plants get larger and larger in this case. In the United States, our caves are not big enough and our climate is not warm enough right now that, you know, we don't see this kind of transition. We kind of, if we're in a cave, there's, you know, minimal to zero plants, and then you step out and all of a sudden there's plants. But you can get these gradual transitions in these giant Southeast Asian caves. And this is Doling 2. So even huger than Watch Out for Dinosaurs. This Doling is 163 meters across the floor. So we have full trees growing in here. So this is more, the plants in here are more like the jungle that surrounds the cave than in the other Doling that we saw. And if we look over here, we should see something that harkens a little bit back to some of our plate tectonics discussions. Here's some faulting in the rocks where there's been breakage and one layer of rock has moved relative to another. And there's really too much vegetation to be able to tell quite what kind of fault we're looking at. That sounds fantastic. Write a grant proposal and I'll make the logistics happen. And so we're up in the forest now. So this is the forest in. If you look at the map over here, we're still in the cave. So this is still Sandoon Cave, but we're in Dolomite. And still moving through Doong 2. Right here. Okay. Yes. That is so cool. Is it endangered?
I don't think so.
No. They're discovering all kinds of species in this cave that are protected by these dolines that are endangered or threatened.
It might be a different one than the one that was in New Guinea.
Okay.
But it looks very similar to the we basically have a jungle in our living room.
That's awesome.
Yes.
And there's the end of Doling 2, and that would take us back into the cave. Yeah, they don't do tours at this time in this cave. This cave requires special permits, and it's just in an exploration phase at this point. I haven't seen anything that requires cave diving in this cave. I don't know that it won't that it doesn't have those things, but. Probably just one permit, but it wouldn't be easy to get. So this is the lower part of the cave. And this is in the complete dark zone. So they have found completely new species in this cave that have been found no place else. A new woodlouse and a new fish. And FYI, it is 3:15. So if you need to go, then you may go. And this is really cool.
This is a really cool class, so thank you for it.
Oh, you're welcome. Have a good read. Awesome. We've got a few people. Tanner's still here, Max is still here. See you, Ken, thank you. Oh.
Oh, fell out of the pocket.
Oh, okay.
Could be from December if that's. Oh.
Okay.
Could be from the
Take care. Ah, that would make sense. Okay.
I had
Oh, wow.
yeah. It's
Okay, cool. The Lake of Sandoon.
oh, it's in what? Oh, it's a roly poly.
Oh, cool.
Yeah, wildlife are roly poly.
Okay.
That roly poly, I'm more closely related to
Wow.
yeah, no, if you look at the, I forget what it's called, isn't it like an arthropod or something like that? But if you look at them real closely, you can tell that they kind of look like the sea creatures that kind of move around on the seafloor.
Yeah.
So this is the part of the cave at which, if one had cave diving expertise, it would maybe be possible to continue the exploration. But the exploration of this cave is so recent that this is as far as it goes. Is this so this is, what do they have a name for this lake? I don't know if this, I'm sure it does have a name, but Lake of Sandoon, is that what we said? Okay. And so it's what's called a sump, and that's where the passages up ahead have filled and kind of backed up, and you get this pond of water, and that's as far as yep, that's as far as our tour goes. People just stuck around 3 more minutes.
Yeah.
They didn't miss that much though. That's... Oh, Audrey's still here. Hi. I didn't see you over there. Did you forget, is this yours? There we go. This is the last one. Okay, folks, well, that's the new time. There are caves that do not have any trails in them that
would be accessible to the public. And I can say that confidently because people are finding new caves every year. And